Okay, so we're on scenario 7. Ah. Um, so we're gonna find the elimination rate constant after a single milligram IV bolus of neostigmine has been administered. So the first way to find the elimination rate constant is to do concentration 1 over concentration 2 over time 1 minus time 2. Notice that this is in nanograms per milliliter. These will be eliminated out here, so don't worry about them in 15. But I believe in 16, when we get there, I think we'll have to worry a little bit about it. All right, so you guys have seen this equation several times. It is right here. If you're during the exam, you can see a similar question, you can figure it out right away where to look. Okay, so first concentration is 78.8 over 15.9. If this was not a ratio, this would not work, and I would have to convert, and I'm very glad I don't have to. And you plug that into your calculator, and you should get negative hours. No, inverse hours. But I don't know why I've called them negative hours forever, and I know they're wrong. All right, so that one's very simple. You now have the elimination rate constant. Hooray, you now have that. Okay, so the second one asks you for the initial drug concentration at time 0 hours. So you're going to use this equation with this equation, just like we did earlier. So you're going to substitute that there. You're going to put that in there. And then you're going to find time, and you're going to put it there. And we just found the rate constant. So if that's confusing, I will explain. So number 16. So initial drug concentration. So you take Ct equals C0 to e to the negative KET. So we know that 78.8 nanograms per milliliter is equal to CO to e to the negative 0.8003 inverse hours times 1, which makes this super simple, so then that just disappears. So you find that concentration 0, when you take 78.8 divided by e to the negative 0.03, so that would be like this. Sorry. I'm getting ahead of myself. So that will equal your concentration 0 like that. And you will find that is 175.43 nanograms per milliliter, because these do not eliminate out, these will stay. But if they ask you what it is in milligrams per liter, you'll have to convert that, which I believe you multiply it by 10, because you might divide it by 10, because the nanograms, to cancel them out, I believe it is 10,000 nanograms for every single milligram, and then for every milliliter, there are 1,000 milliliters per liter. So it breaks down to dividing by 10, if I remember correctly, because micrograms is 1,000, and that would be a 1-to-1, and this would be so much simpler. So you just move that over if they ask for milligrams per liter. That's all. So watch your units, because obviously they be trying to trick you. And that's how you solve that one. So, so if you want it in milligrams per liter, which they might ask for it, they might just like, oh, what is this in milligrams per liter? Make sure you pay attention to your units.